All right, so you all should have a note sheet from today. Your note sheet is going to be a little different than my note sheet just because I didn't want to fit it all on one slide, so I broke it up into a couple of different slides. So first off, we're going to graph a systems of inequalities today. I wanted to get all of the graphing out of the way so that part is done with, and then we can just get back into more algebra type things. Okay? So we graphed systems of equations on Monday, and that was finding one particular point in space that made all of the equations in our system true. Okay? Now we're going to graph a system of inequalities. So now, because we're dealing with inequalities, we graphed single inequalities back in first semester, way back in Unit 2. We looked it up back in October, beginning of October, we graphed system of inequalities. And so now we're going to look for an area on our graph that makes all of our inequalities be true. Okay? All right? So first step is you're going to treat, so this right here, let me get it going here. This right here is my system of inequalities. Okay, so we have two inequalities in this one. So the first step is we're going to treat each individual inequality as if it was an equality, and then we're going to graph it. So what I mean by that is, so I'm going to take the first one first. So I'm going to treat y is less than or equal to 3x plus 2 like it was y equals 3x plus 2. And I'm going to graph y equals 3x plus 2. But because my original problem was an inequality, I have to remember that if it's less than or if it's greater than, that makes my line be dashed. Okay, so those would be a dashed line there. If it's less than or equal to or greater than or equal to, then that is going to be a solid line. So since this one here had the equals component in it, that's going to be a solid line for that. Okay? So I would go to positive 2 for my line intercept. Then from there I would go up 3, 1, 2, 3, right 1. 1, 2, 3, right 1. Or I could go down 3, left 1. Then I'm going to graph that line. With a solid line. Then, because it's an inequality, there is going to be some shading involved. Okay? So I have to pick a test point. If I don't go through the origin, I should pick the origin as my test point. Plugging that back into my original inequality, 0 is now y, less than or equal to 3 times 0 plus 2. 3 times 0 is 0, plus 2 is 2. And so I'm asking the question, is 0 less than or equal to 2? That's a true statement. So I would shade on the side of the origin. But now let's tap the brakes here for a second. Because we have another inequality to go on this graph, I'm not going to full-on shade yet. What I'm going to do is I am just going to draw in some arrows signifying that that's the side of that line that I am going to graph. With me so far. Step 2 then would be now I need to rinse, lather, and repeat that process for any and all other inequalities within my system. So now I'm going to look at this graph of y is greater than negative x plus 4, and I'm going to graph that as if it was y equals x plus, or excuse me, negative x plus 4. So that would have a y-intercept of positive 4, and then it would have a slope of negative 1, which would be down 1 and right 1. Or up 1. That line, because it doesn't have the equals component, is going to be a dashed line. We will also have to repeat the process of test point. Didn't go through the origin, so I'm going to use the origin once again. 0 is greater than negative 0 plus 4. Negative 0 is 0 plus 4 is 4. Is 0 greater than 4? Here you go, Sarah. Here's your chance. 0 greater than 4. Come on, Sarah. Oh, I was going to say, you had me scared there for a minute. You and your first witness. Okay, so that's false, right? So because that is false, that means I'm going to shade away from the origin. I'm going to draw arrows on this side of that line. And then once again, I would do that process again if I had more. Sometimes I might have 3 inequalities, I might have 4 inequalities, etc., etc., etc. So now I'm sitting with here, and now my final answer is going to be the section of the graph that has all of the arrows in it. So this section over here has 0 arrows in it. This section up here only has 1 arrow in it. This section down here only has 1 arrow in it. But this section over here has both of the arrows in it. So therefore it is going to be the area that I then full on shade in. Whoa, tap the brakes. Went a little too close to the line there. Creative pens sometimes get a little too creative. And that's where it is. Okay? Questions on that? Yes. No, there is not. Yeah, because all of those points in that shaded area make this system be true. It's not just a one point shot deal like it was on Monday. Okay? What I would like you to do now is I would like you to turn your note sheet over and attempt number 2, please. Number 2. All right, so x is greater than or equal to 2. I'm going to graph that like it was x equals 2. That's going to be a solid line. It is going to be vertical, and it's going to be at positive 2. Then, didn't go through the origin, so I can run a little test point action of 0, 0 on it, plug in 0, get that. That is a true or a false statement. That's false, so I wouldn't shade towards the origin. I would shade away from the origin. Okay. Then going on to 4x plus 3y equals 12, subtracting 4x, dividing everything by 3, gives me that. That's a y-intercept of positive 4, a slope of negative 4/3, so I would go down 4 and right 3. Down 4 and right 3. Down 4 and right 3. Or I could go up 4 and left 3. That one is going to be a dashed line. That one did not go through the origin either, so I can use the test point of the origin for that one. 4 times 0 is 0. 3 times 0 is 0. 0 plus 0 is 0. Is 0 less than 12? That is true, so I would shade on the lower half of that one, but I'm not going to worry about drawing my arrows over in this general area. I'm only going to draw them over here because that I got to be where all the arrows are. So I'm going to leave that one there. Then I go to the last one. So that's going to be like negative 3x plus y equals negative 1. So that's going to be y equals positive 3x minus 1. So that would have a y-intercept there. Positive 3, 1, 2, 1, 2, 3. 1, 1, 2, 3, 1, 1, 2, 3, 1. Or I can go down to be 1, 2, 3, left 1, 1, 2, 3, left 1, 1, 2, 3, left 1. That's going to be a dashed line itself. Came extremely close to the origin, but I didn't go through the origin. So I am going to test the origin. Negative 3 times 0 is 0. Plus 0 is 0. 0 is not less than negative 1. That is false. So I am going to shade on this lower right-hand side of the line, which gives me the only spot that this one happens to be in is this little area, this little triangle region. Right there. Okay. If you haven't done so already, please try number 3. So I need to graph y equals 2. That is going to be a dashed line. It is going to be 2 up from the origin. Right there. And go through the origin, so we can use a test point of the origin. 0 less than 2, true or false? That's true. So that means that I'm going to be shading on the lower half of that line. Now, mean old math teacher, making you remember all the way back to October. What shape is an absolute value graph? The V. Okay? Okay? So the vertex of that V is going to be at the point 2, comma, -1. I think opposite with the X value. I think straight up with the Y value. Bless you. Okay? So I go through the point 2, comma, -1. That is going to be the bottom point of our V. If we don't remember all of these steps, we can always use a T-chart to find it. Then it said that, or then we learned that the right side slope of our absolute value V is going to be that number out in front. So that's going to be a +2. I'm going to go up 2 and right 1. My left side slope is going to be -2, the opposite of that. But I'm not going to go down and left. No, no, no. Or down and right, I should say. I'm going to go up and left. Those then are rays. They are going to be solid rays. Could be dashed, but in this particular case, they are solid. I did not go through the test, or excuse me, I did not go through the origin, so I'm going to use the origin as my test point. 0 in for Y, 0 in for X, and then I've got to do that math. 0 minus 2 is -2. The absolute value of -2 is 2. Times 2 is 4, minus 1 is 3. So I have 0 is greater than or equal to 3. True or false? That's false. So with the absolute value, it's either inside or outside. Since my test point was on the outside, that means that I am going to shade the inside of my absolute value, which means that the only spot that's left over then for me, or where they both are, would be this little triangle in here. And that then is my final solution area. Okay? Now, we can also work backwards with that based off of the graph. It's just the reverse of what we just happened to do. So first off, I would start with the line or the absolute value or whatever it is that you have graphed. In this particular case, in number 4, we have a line graph, and that line has a y-intercept of +3. It has a slope, a rise over run, of +1. I'm going up 1 and to the right 1. So this line would be y equals x plus 3. But I need it to be an inequality because there's some shading involved. So I'm going to keep the y. I'm going to keep the x plus 3. I just need to fill in the inequality there. So I'm looking at this test point of the origin. So if I put the origin in there, oops, I shouldn't put that there. I should get rid of this, and I should just put a random old box. Okay, 0 plus 3 is 3. I need this to be a true statement. So I need the alligator to eat the bigger part, but because the line is solid, we're going to go with less than or equals sign. So that would be my inequality for that particular graph. If we have a system of inequalities, like we have going on here, again, I would repeat that process. My b here would be 3. My slope would be 1. I just did the exact same line as what I did there. Okay? So then this one is going to be y is less than or equal to x plus 3 because it's shaded on the same side as the one you just did. So I have to repeat that process. Okay? Then I've got to look at this line right here is a vertical line. So that is an x equals line. And that's at 1, 2, 3. So it's x equals 3. If I make my test point be the origin once again, I need x to be a falsitude, excuse me, not x there, pardon me, that should be 0. I need this to be a falsitude, so I need it to be dashed, so it's going to be that one, greater than, so x is greater than 3. And that then becomes that system of equations. Okay? This week you will have a formative on Friday and probably a summative quiz next week, Friday. And then still haven't decided on test date yet.